Woo, we're live. Okay, this is Math 40, section 3.5. And this is page number deux. Where's my fingers? There, deux. And we're going to go ahead and use slope-intercept form to graph this line, which I'm very excited about. So first thing is to notice that this is not in slope-intercept form. This is actually in something called standard form, where the x and the y are on the left side and the numbers on the right. Ugh, seriously, people, let's get with the program. So first thing I'm going to do is I'm going to rewrite this in slope-intercept form because it says I need to use that. So I'm going to do that by just the lighting a little bit. So first thing I'm going to do, we could do shadow puppets. This is like an angry porpoise wearing a weird hat. Okay, so I'm going to subtract 2x from both sides. So then I get 2y equals negative 2x minus 6. Next thing I'm going to do, I've got 2y equals negative 2x minus 6. I'm going to divide both sides, every term by 2. Like that. So basically what I'm trying to do is get myself to the point where I've got y equals the opposite of x minus 3. Now, could you have done this a different way? Absolutely. There are a couple different ways I can think of to solve for y. But ultimately, what you want to do is you want to get y all by itself isolated, and then you've got slope-intercept form. So if y equals the opposite of x minus 3, then I know that the slope is, you got it, negative 1. And b is negative 3, which means you've got a point 0, negative 3. So what does the slope tell me? The slope tells me that I'm moving in a negative direction. So the line's actually going to look like that. And also, I'm going to take us back to triangle land. Now, this is going to be a different way of graphing, a really different way of graphing. The way I'm going to graph this is, rather than plotting a bunch of points, is I'm actually going to use the slope. And I'll remind you that the slope is rise over run. And so negative 1 tells me that if I move over 1 in the x direction, I move 1 down in the y direction because it's negative. If it were positive, I'd go up and I get a new point. So that's what my slope looks like. Okay, so what point am I going to start with? That's a good question. I am going to start with the point 0, negative 3. So let's see, 0, negative 3 is on the y-axis. So I can draw a straight line here. Yet again, I've forgotten to grab my ruler. So this is as straight as I'm going to get today. I know, humorous. Yeah, I've got all this funny stuff happening. I've got the x-axis, I've got the y-axis. Of course, you guys are not professionals. Please use a ruler. Don't hurt yourselves. 0, negative 3, I'm just going to go ahead and use the standard scale. 1 square is 1. And here's 1, 2, 3, 4, etc. 1, 2, 3, 4. Now, here's how I use the slope. Slope is negative 1. So I move over by 1. I go then down 1, and I've got another point. I move over 1 and down 1, and I've got another point. Notice I now have 3 points. And again, you guys should use a ruler. Don't be foolish. Save yourselves. And you can draw the line without ever having to worry about plotting points individually the way we were before. Now, could you do a table of values? Absolutely. So if we did a table of values for this, let's see, where am I? I've got my y equals the opposite of x minus 3. So at x equals 0, y equals -3. At x equals 1, y equals -1 minus 3 is -4. Let's look. X equals 1, y equals -4. Bam. So we've got a brand new way of graphing with this one. If you want to graph using slope, you're always welcome to graph using slope rather than a table of values. Could you always use a table of values? Yes. Could you graph using the slope and then transfer these numbers onto a table of values? And then I would never know what you did first. Absolutely. You've got choices. Math is all about choices because math loves you. Okay, shall we talk about another problem? What else can we do? Well, now, if we've got two graphs, two lines, I should say, line 1 has y equals 4x plus 6, and line 2 has x plus 4y equals -2. So I've got two different lines, and I want to know if they're parallel, perpendicular, or neither. So what's the way to figure that out? Well, you need to know what the slopes are. So the really nice thing is this first line, the slope is, you got it, Dora fans, the slope is 4. Now over in line 2, they're being kind of obnoxious. Which is me being obnoxious because I wrote this problem. And the problem here is that we don't have it in slope-intercept form, so you can't just read the slope off. So I'm going to go ahead and solve for y. I subtract x from both sides. Okay, I got 4y equals the opposite of x minus 2. Then I'm going to have to isolate y, and look at me knowing I'm remembering to raise the paper. I'm going to divide all terms by 4. I'm totally running out of room. Y equals -1/4 x minus 1/2. Do you see that? If I pull the x out, I've got -1, because if I just have the opposite of x, that's -1 times x. You don't write the ones in, so it becomes -1/4. Okay, so what's the slope over here? Over here, the slope is -1/4. Now, if you take a look at these two, do they have the same slope? No, so they're not parallel. Do they have opposite reciprocal slopes? So positive, negative, 4, 1/4. Yep. So they are opposite reciprocals. Yes. These two are opposite reciprocals. These are perpendicular lines. Yay, and we have yet another page of lectures done. Woohoo! Are you guys ready? We got one more page for this section. I'll meet you soon. Same bat time, same bat channel.